In this type of problem, we're given three charges again, but this time they are not in a straight line. Instead, they're in a triangle formation. And we're asked to find what is the total force on charge 6. So once again, I'm going to put a box around charge 6. That's the one that we are investigating. So what we'll do is we'll find out how much charge 4 exerts a force on that and how much charge 3 exerts a force on that, and add them together to get a total. So let's first start by finding out how much of a force there is on charge 6 because of charge 4. So again, our notation is the force on charge 6 because of charge 4. And so that is K Q6 Q4 over R squared. Our values here, we have our K times 6 nanocoulombs, which is times 10 to the negative 9th coulombs. And then we have 4 nanocoulombs, which is again times 10 to the negative 9th. Divided by the distance, now it's 0.4 millimeters. So that it needs to be converted to 0.0004 meters. And don't forget to square that value for your distance. We get the force then between 6 and 4 comes out to be 1.35 newtons. And so we want a direction as well with that, and they are both the same charge, and so they repel each other. So if we look here, charge 4 is going to be pushed upwards, and charge 6 is going to be pushed downwards. They're going to repel or move away from each other. But we're only focused on this charge. So the direction of the force on this charge, on charge 6, is downward. All we're concerned about is the force on charge 6. And now we want to find out what is the force on charge 6 because of charge 3. So again, it is KQ6 Q3 over R squared. And so our values, we have K, we have 6 nanocoulombs. Remember, nano means negative 9. I have that alliteration. Nano is negative 9. And then we have 3, and we leave off the negatives. We'll get our direction just by conceptually thinking about if they attract or repel. So 3 times 10 to the negative 9, all divided by our distance. Now this distance we actually do not know, but it is a right triangle, and so therefore we can use Pythagorean theorem to get that distance. So 0.4 and 0.3, we need this distance, which is our unknown, our hypotenuse. So Pythagorean theorem says that the hypotenuse squared is equal to the sum of the squares of the sides. And so our hypotenuse squared is 0.4 millimeters squared plus 0.3 millimeters squared. And so we get that that distance is 0.5 millimeters. You might have already known that it's a 3, 4, 5 triangle. So here we have 0.5 millimeters. But we need to convert this to meters. So it's 0.0005 meters, and don't forget to square that. Now if I'm doing this in my calculator, well, a shortcut here is to just do second entry, bring up this one again, bring up this calculation again. All we have to do is replace the 4 with the 3 and replace this 4 with the 5. It'll make your life a lot easier, a lot simpler if you learn how to use the shortcuts on the calculator. We get this, comes out to be 0.647 newtons. But now we need a direction. And so if we look at these two, they are opposites, and so they attract. So charge 3 is going to be attracted towards charge 6, and charge 6 is going to be attracted towards charge negative 3. And so we can see that the direction on charge 6, this is what I'm concerned about. Charge 6 is going to be up and to the right at an angle. But we're going to have to figure out what this angle is. So what exactly is that angle there? And we'll do so through our trigonometry. So our triangle is, we'll do so with our distances. We have 0.4, 0.3, and 0.5. And we need to find this angle. And so I would say Then you can use a few options, but we're going to use our inverse trig functions. I would say use the inverse tangent. And tangent is opposite, which is 0.3, over the adjacent, which is 0.4. Adjacent side is the side that's touching it, but is not the hypotenuse, and the opposite is one across from it. And so we get that this angle comes out to be 36.9 degrees. So we go back here, and it's this angle here with respect to the vertical, 36.9 degrees. Now what we have to do here is we actually have to break this into its x and y coordinates. So we have a triangle here. And we want to break this into its x and y coordinates, knowing that the hypotenuse is 0.647. So if I come here and clear this off, I'm going to find this side, which I'll consider my Fy, or my F parallel. I guess I should use that notation since that's what we used earlier this year. So this would then be my F parallel. And I have my F perpendicular. And my hypotenuse was this 0.647 newtons. And my angle was 36.9 degrees. So the way that I'm going to find those two components is I'm going to use my sine and my cosine. So I have first, let's find this perpendicular component. And so the perpendicular component we are going to get as the sine of 36.9 degrees is the perpendicular component over 0.647. And we get the perpendicular component comes out to be 0.518. And that would be upward. To get the parallel component, we'll use the cosine. And the parallel component comes out to be 0.388. And that would be then to the right, because our direction was up and to the right. So now I can go back here. I can write in my two components. We had that the perpendicular component was 0.518, and that was up. And the parallel component was 0.388, and that was to the right. We are going to replace this one vector with its two parts, so we'll never use that 0.647 again. We're replacing the one vector with its two components, with its two parts. So now I essentially have three different vectors, and I want to find the total of those three. The way that I do so is first, I find the total force in the x direction. There is only one force in the x direction. It's F parallel down here. That is 0.388 newtons, and it's to the right. But there are two forces in the y direction. So if I find my total force in the y, I have 1.35 newtons, which is down, so that's negative. And I have 0.518 newtons up, so that's positive. And I get my total comes out to be negative 0.832 newtons. And that simply means 0.832 newtons, the negative means down. So the progression here is find those individual forces. If necessary, break them into components. Find the total x and the total y. Now that we have the total x and total y, we're going to redraw this right triangle. We have that it is 0.388 newtons to the right. And we have that it is 0.832 newtons down. And we want to find the hypotenuse, which is the overall force on charge 6, as well as that angle. Whenever you find a force, unless it specifies otherwise, you always want an angle. So find that total force on charge 6 using Pythagorean theorem. So total force squared is equal to the sum of the sides squared. And so we get the total force on charge 6 comes out to be 0.918 newtons. But we also need an angle, and so to get the angle, again, we'll use our inverse tangent. To get angles, use inverse functions. And we'll use the inverse tangent, so it's opposite, 0.832. Divided by the adjacent, the side touching it, 0.388. And that gives us an angle of 65 degrees. So here's my total magnitude and my direction. So if I want to write it all in one spot, and my angle would be 65 degrees, and we must have this angle labeled within our picture. So we need to have that picture over on the side so we have it labeled properly.